Have you ever wondered what your phone, your car, and the Eiffel Tower all have in common? Well, the answer lies in the fascinating world of materials science, a field that is as intriguing as it sounds: materials. Science is the study of stuff, everything you can touch, see, and feel. It's the science that tells us why a window is transparent, why a car is strong and durable, or why your phone is so light yet so powerful. But it's not just about understanding the properties of materials. It's about designing and creating new materials to solve problems and improve our lives. Think about it. Every object that surrounds us, from the mundane to the extraordinary, is a symphony of materials working together in harmony. That's the magic of material science. In the realm of engineering and technology, materials science plays a pivotal role. It's the cornerstone that bridges the gap between scientific theories and practical applications. From designing aircraft and skyscrapers to creating biodegradable plastics and superconducting materials, this field is revolutionizing the way we live, work, and play. Now, materials are broadly categorized into four types: metals, ceramics, polymers, and composites. Each type has its own unique set of properties and uses. Metals, for example, are known for their strength and conductivity, ceramics for their hardness and heat resistance, polymers for their flexibility and lightness, and composites for their ability to combine the best traits of other materials. We'll delve more into each of these types in the upcoming scenes. So, to answer our opening question, all these objects, your phone, your car, and the Eiffel Tower, they're all made using principles of materials science, and that's just the tip of the iceberg. As we dive deeper into this fascinating field, you'll discover that material science is not just about understanding the world around us, but it's also about imagining and creating a better future. Imagine a world without metals. Difficult, isn't it? Metals are everywhere, and for good reason. They have a unique combination of properties that make them indispensable in our daily lives. Let's begin with physical properties. Metals are known for their luster, the way they reflect light. This makes them ideal for decorative purposes, like jewelry and architectural accents. They're also excellent conductors of heat and electricity, which is why you'll find them in everything from your kitchen utensils to the wiring in your house. Now think about the structure of metals. At the atomic level, metals have a crystalline structure. This means their atoms are arranged in a repeated pattern, like a three-dimensional checkerboard. This structure gives metals their characteristic strength and malleability. Malleability is the ability of a metal to be hammered or rolled into thin sheets. Think about aluminum foil, which is so thin that you can literally see through it, yet strong enough to wrap around your leftover pizza. But metals aren't just about being shiny and strong, they're also incredibly versatile. They can be alloyed, meaning two or more metals can be combined to create a new material with improved properties. Take stainless steel, for instance. It's an alloy of iron and chromium, and it's known for its corrosion resistance. This makes it ideal for applications where durability and hygiene are critical, like in kitchen appliances and medical instruments. The uses of metals are as varied as their properties. From the copper in your computer's microchip to the steel in your city's tallest skyscraper, metals are the backbone of modern technology and infrastructure. They help us build stronger, last longer, and reach higher. Metals are so much more than just the stuff things are made of. They're the silent heroes that hold our world together, often overlooked but always essential. From the smallest microchip to the largest skyscraper, metals play a crucial role. Their strength, durability, and versatility make them an integral part of our lives, and it's hard to imagine a world without them. So the next time you pick up a metal object, take a moment to appreciate the science and engineering that went into it. Ever broken a ceramic plate? Then you've experienced firsthand one of their defining characteristics. Ceramics are fascinating materials with unique properties. They're a diverse group of materials, including everything from bricks to glass, porcelain to advanced ceramics. At their core, ceramics are non-metallic, inorganic solids. They're made by heating raw materials, often including clay at high temperatures, a process known as firing. One of the main characteristics of ceramics is their hardness. They're actually among the hardest materials on Earth. This hardness comes from their crystalline structure, where atoms are tightly packed in a repeating pattern. This structure makes ceramics resistant to wear and tear, and able to withstand high temperatures, but with great hardness comes great brittleness. Yes, ceramics are brittle. They can withstand a lot of pressure, but apply it in the wrong way or at the wrong point and snap. This is why your ceramic plate shatters when you drop it. Despite this brittleness, ceramics have a wide range of applications. They're used in everything from kitchenware to construction materials, electrical insulators to heat shields on spacecraft. Why? Because ceramics have another superpower. They're excellent insulators. They don't conduct heat or electricity well, which makes them perfect for these uses. Ceramics are also used in the medical field. Bioceramics, like artificial bones and teeth, are designed to be compatible with the human body. Imagine the same stuff that goes into your coffee mug could be used to replace a hip joint. It's worth noting too that not all ceramics are created equal. Advanced ceramics, also known as technical or engineered ceramics, are designed to have specific properties. They're stronger, tougher, and more heat-resistant than traditional ceramics and are used in everything from electronics to jet engines. So next time you use a ceramic mug, appreciate the science that went into creating it. What do plastic bottles, rubber bands, and DNA all have in common? You might be surprised to learn that these seemingly disparate things are all examples of polymers. Polymers are large molecules made up of repeating subunits known as monomers. Their properties, structure, and uses are as diverse as the materials they make up. Some polymers, like the ones in your favorite sweater or car tires, are incredibly durable and can withstand a lot of wear and tear. Others, like the polymers in DNA, are delicate and intricate, playing a crucial role in our biological processes. The versatility of polymers is truly remarkable. This is largely due to their structure, which can be altered to achieve different properties. For example, by changing the arrangement or type of monomers, we can create polymers that are hard and rigid, like the plastic used in food containers, or soft and flexible, like the rubber in a bouncy ball. Furthermore, the way polymers interact with each other and with other substances can also be manipulated to create materials with unique characteristics. This is why polymers can be found in everything from spacecraft to medical implants. Their widespread use isn't just limited to industrial applications. Polymers also play a crucial role in the field of biotechnology. For instance, they are used in drug delivery systems to transport medicine to specific parts of the body. And of course, DNA, nature's own polymer, is at the heart of all living organisms. But the world of polymers isn't static. Scientists and engineers are constantly discovering new ways to make and use these amazing materials. From developing biodegradable plastics to creating polymers that can conduct electricity, the possibilities are endless. So, the next time you take a sip from a plastic bottle, stretch a rubber band, or even when you look in the mirror, remember, you're interacting with the fascinating world of polymers. Polymers truly are the building blocks of life and much more. What if you could combine the strength of a metal with the lightness of a polymer? Well, in the realm of materials science, we can, and the result is what we call composites. Composites are fascinating materials born from the union of two or more different substances, each with its own physical and chemical properties. When these distinct materials come together, they create a composite that possesses a combination of their best characteristics. Imagine a superhero team where each member brings a unique power to the table. Much like this, each constituent in a composite contributes its unique strength, resulting in a material that's stronger, lighter, or more resistant than its individual parts. Let's delve a little deeper into the structure of composites. They're typically made up of two main parts, the reinforcement and the matrix. The reinforcement is the part that provides the strength and rigidity. This could be fibers, particles, or even sheets of a material. The matrix, on the other hand, is what binds these reinforcements together, providing shape and protecting the reinforcement from damage. One of the most common examples of composites you'll find is fiberglass, a material often used in boat hulls, sports equipment, and even in the aerospace industry. Here, fine strands of glass serve as the reinforcement bound together by a matrix of plastic. The result? A material that's both strong and lightweight. But that's just scratching the surface. Composites are all around us, from the carbon fiber used in high-performance cars and bicycles to the concrete in our buildings. Even natural materials like wood are composites, consisting of cellulose fibers embedded in a lignin matrix. By strategically combining materials, we can engineer composites to suit a wide range of applications, tailoring them to withstand specific environmental conditions or handle particular loads. This is the power of material science. The ability to manipulate and combine materials on such a fundamental level opens up a world of possibilities. Composites, the best of all worlds. The blending of unique properties to create materials that are truly more than the sum of their parts. That's the magic of composites in material science. What do spider silk, graphene, and self-healing materials have in common? They are all part of the exciting future of materials science. The field is constantly evolving, and the developments we see today are nothing short of revolutionary. Take biomimicry, for example. This is the practice of designing materials and systems that mimic biological processes. Spider silk, one of the strongest materials known to man, is a prime example of this. Researchers are studying its structure and properties in the hopes of creating stronger, more durable materials. Imagine a world where buildings can withstand earthquakes or bridges that are impervious to wear and tear, all thanks to the humble spider. Then there's the world of nanomaterials. These are materials that have been manipulated on an atomic or molecular scale. The most famous of these is graphene, a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. It's incredibly strong, yet flexible and almost transparent. It conducts heat and electricity efficiently, and it's lighter than a feather. The potential applications for graphene are vast, ranging from electronics to energy storage to medicine. And let's not forget about smart materials. These are materials that can change their properties in response to external stimuli, like light, temperature, or pressure. Self-healing materials fall into this category. Imagine a smartphone screen that can repair itself after a crack, or a concrete road that can fill in its own potholes. With smart materials, this could become a reality. These developments in materials science are not just fascinating. They have the potential to revolutionize technology and society as we know it. They could lead to stronger, lighter, and more efficient materials that can withstand the harshest conditions. They could transform industries, from construction to electronics, and even alter the way we live our daily lives. The future of materials science, it seems, is as exciting as it is limitless. So what have we learned today about materials science? Quite a lot, actually. We've journeyed through the fascinating world of metals, ceramics, polymers, and composites, each with its unique properties and applications. We started with metals, the backbone of our industrialized world. From skyscrapers to spacecraft, metals are indispensable. We discovered that metals are known for their strength, ductility, and conductivity, and we delved into the alloying process that allows us to enhance these properties. Then we moved on to ceramics. Far beyond the realm of pottery and tiles, we found ceramics in everything from engines to electronics. We learned about their high melting points, hardness, and brittle nature. Despite their fragility, ceramics have a high resistance to wear, corrosion, and heat, making them valuable in numerous applications. Our journey then took us to the world of polymers, those long chains of repeating units that make up the plastics and rubbers we use every day. We explored their flexibility, resilience, and ability to be molded into virtually any shape. We also touched on the environmental impact of polymers and the urgent need for sustainable alternatives. Next, we ventured into the realm of composites, where two or more materials combine to create something that's more than the sum of its parts. We discovered how composites like fiberglass and carbon fiber composites are lightweight yet strong, opening up possibilities in fields like aerospace and sports equipment. But that's not all. We also looked ahead to the exciting future of material science. We discussed how ongoing research and development are paving the way for new materials with astounding properties. From self-healing materials to metamaterials that can manipulate light, the possibilities are endless. As we've seen, material science is a dynamic field that touches every aspect of our lives. It's a discipline that pushes boundaries, solves problems, and drives innovation. Whether you're intrigued by the science, drawn to the potential for invention, or inspired by the impact on society, there's a place for you in this exciting field. So, what's next? Keep exploring, keep questioning, and keep learning. The world of materials, Science is vast and ever-changing, and there's always more to discover. If you've enjoyed this video about material science, why not give this video a thumbs up? Your likes are the compass that guides us in creating content that you love. And if you're already a part of our VIP-loving community, thank you. You are the wind beneath our wings. If you're new here and you found value in this video, consider joining the family. Hit the subscribe button and the bell icon to ensure you never miss out on a new material science video.